Hello. You can see me?
Okay, so any questions before we get started? So on the screen, you can see a QR code, right? So take your phone, scan that code. We're going to use something called a Slido to improve our engagement, okay? Anybody know what Slido is? Anyone use it before? So it is like a platform that we are going to use. Okay, I know some of the students, if I ask, does anyone have questions? So you will never actually raise your hand. Okay, but this allows you to actually just use your phone to enter your questions. Okay, once you enter your questions on your phone, you should be able to see all the questions posted by your classmate. Some of the questions that you may actually have the same, maybe it's actually the question that you want to ask. You can actually upvote those questions, okay, and then you actually pop out on the platforms, and we actually address those questions along the way. All right, so what we'll do is actually, I will actually go to the website. So it's going to pop out all this information in real time. Okay, so I can actually know what are the questions that you have, and I can address those questions for you in real time. Okay, I want to emphasize that this course is a calculation heavy course. Okay, let's actually no other way out. You need to know how to do all the calculation quickly. That's actually the only way that you can get the grade that you want. Okay. So the best way is actually really figure out how to do a calculation before you step out of this room. That is actually the best strategy that you should actually have. Okay, don't wait. Okay, don't go home. You think you can actually ask your friends. No, you won't be able to do that. You are too busy. Okay, so the best way is actually figure out how to do all the calculation before you go out of the room. Okay, and then the way you know you can actually do all the calculations that you ask the correct questions. Okay, so it is essential. So on your phone, you should see one is actually a pool, right? So I actually use this one to let you know whether you will be able to operate on your phone. Okay, so that's one column called the pool. The other one is actually called the Q&A. You can just type out the Q&A. Okay, then we can actually see the content of Q&A. Okay, so I'm going to show you really quickly. So these are the Q&A. Okay, there are actually already 8 questions have been entered by your classmate. Right now, it's actually this appear on the screen. Okay, so if any questions that is also fits in your interest, then upvote it. Then we can actually address these things along the way. Okay, so the first questions, for example, okay, would you have multiple practice exam for midterm 1, or it's just the one on Cengage? There will be only one practice exam on Cengage. There will be actually the only one that you can have. Okay, everybody have access to that. Okay, but if you look at our Hangout, we have the questions for each chapter, right? We also have a Hangout that has many questions for your midterms and finals. If you can learn how to just solve all the questions that I posted according to the statistics from my past students, it seems like if you can really actually do all those questions, you have no problem getting an A for your midterm and finals. But again, the key is, can you actually solve the problem quickly and accurately, right? So in order to do that, the most important skill that you want to have is that when you read the questions, can actually identify the keyword. Okay. Once identify keywords, can actually connect back to the essential concepts, essential equations. Okay, then you should be able to solve those things quickly. Okay, so that will be actually my answer to the first questions. All right. Any other questions associated with the first one? Okay, so if not, then I can say check, then that question will disappear. Cool, right? So this is actually how we are going to communicate. How many of you actually used this before? Never? See, I'm young, I'm innovative. Okay, so trust me, I actually spent time trying to figure out how to actually improve our communications. Okay, I will always ask, okay, do you have any questions in the beginning of the class? Okay, but my experience is that we have too many kids here. It's really difficult for me to actually identify each of you, right? It's too difficult. Okay, so I think this may be actually a better approach to get your attention. Okay, let's look at second questions. What is the average on the exam 1? In my class, last year, the midterm 1, I think the average of, I think back to that time we have 4 sections. The average is actually 65. Okay, average of the 4 sections is 65. My section is 75. Why? Why? Okay, I'm very surprised. Okay, back to the time, because that's actually the first time I try to do this flip class format. Okay, I have a lot of trust back to the time that I tell my student that, okay, you need to actually watch my YouTube video. Of course, subscribe accordingly. Okay, you need to watch that. Okay, so when you come to here, you actually prepared because here, what I want to do is actually want to sharpen your ability to identify the keywords. Okay, I want to reinforce your keywords to the key concept, to key equations, so you can really do the calculation right away. Okay, those are the things you need to practice a lot to get the good grade that you want. Okay, so you're going to hear the same speech over and over again in my lecture. I bring a lot of time for this class. I expect you put in the record time for your grade. Okay. I guess that's the answer to the second question. Okay. Check. This is the same, right? I'm married or not? Yeah, I have 2 kids. Okay. My daughter is actually 10. My son is actually 7. I want to spend most of my leisure time with them. Okay. So my life is actually very simple. 3 things. 1, family. Okay, I like to play with my kids. I want to hang out with my wife. My research. Okay. I've been doing research for 2005 to now is 18 years. Yeah. So I've been a professor for 7 years. Okay. I just got tenure this year. Or last year, sorry. I got tenure last year. So I know I have my job security. Okay, I can continue doing research that I want. Okay, I got funding from the NIH, NSF, which are the 2 biggest federal funding agencies from the United States. Okay, so it's the second thing I like to do. Third things I like to do is what? That's why I spend so much time doing all the things. Okay, but right now I want to actually modify my third things. Okay, I want to be a good teacher, but also a good YouTuber. So you better help me. All right, so if you haven't subscribed, please subscribe now, okay? Okay, so I guess that's the third question. How do you recommend to pass these courses? Work with me. Easy. Do you have review sections? Don't you feel like I'm doing review section right now? Right? So we have Hangout for chapter. Right now it's actually 10, 11, and 12, right? What's after that? Midterm 1, right? What do we do for midterm 1? It's a review. Come on. Right? So that's the answer. Yes, we do. But in a format that's very close to what you're going to have for your midterm. Clear? Okay. You and I have. Who is this guy? All right. Oh, my day is great. Okay, so I want to actually see how these things will look out for this semester. Okay, so I actually keep trying new things, trying to improve my teaching. Okay. For this specific courses, okay, you will get 2 extra points. Okay, and all different instructors have different way to give those 2 extra points. Mine is actually extremely simple. We are going to have 2 surveys. One is actually after your midterm 1. One is actually end of the semester. Okay, you do the survey, you got 1 extra point. The simple as that. Okay, but the things I want to prove from the survey is that I want to know what other things they are useful to help you to improve your study. Okay, what are the things I'm doing correctly that you think is actually you can actually really engage with me and learning the material effectively. Okay, so Jenkins is actually a whole course, right? A course that many different measures you need to actually get familiar with. Okay, not necessarily familiar with, but you need to actually take it. Okay. I think one of the most important things for this core course is that you learn from your instructor how to collect the knowledge in a systematic way, which is not easy. Okay. Most of people actually spend enough time reading the textbook. Okay, but many times I heard so many students come and talk to me, say, okay, Dr. Chen, I spend so much time reading the textbook. I really put in my efforts, but my grade never actually become better. Right? Why? That means actually to translate those knowledge to your understanding is not so efficient. You cannot really get the essence of the really important part. And that's a problem, right? In the end, no matter what you want to pursue in your future, you want to be the best of your own specific field, right? And to actually handle all these questions by yourself, right? What is actually your own way to handle those different things? Okay, my belief is actually there's actually a general rules that can be used to solve all these problems. Okay, so I guess we will talk about a little bit more about that in the future. Okay, and you'll realize that, yeah, even though I'm a Gen Chem professor, right, I actually talk a lot more things that is not Gen Chem related. Okay, I actually want to let you know that the core course, the beauty of core course is actually the material by itself is not that difficult. Okay, but the implication from the learning strategy can be very impactful for the long term. Okay, I always told my students in the past, I'm telling you now that life is long. You need to actually come with a strategy that will work for long term, not just short term. Okay. The reason I show you my Hangout is because I want to give you an example to see how you can actually translate the text in your textbook into some simple lines that you can actually use. Okay, and then install those knowledge into your brain. Okay. It is the same process for all the other subjects as well. Okay, so you want to actually pay attention to that. Okay, identify keywords is actually another thing you probably actually want to be a master, right? When you read a long paragraph or other keywords, knowing the keywords can actually make your life a lot easier. Okay, so those are the things that I think you can actually learn. All right, so how will I randomly? So I guess that's actually things I want to talk about. Okay, if I subscribe, can I get extra point? No. But you'll get my special attention if you come to me. Okay. All right. So where's the? Okay. So I barely passed Chem 1. How much do I need to brush up for Chem 2? Or not really? Talk to me. Okay. So I have an office hour Friday 9 to 11, right? My door is always open. Just go to my office. We can chat. Okay, I have no problem giving you a 1 hour long lecture about how you can do your things. Okay, but you need to actually come to me. Okay, I don't know your specific situation. You need to let me know. All right, so how will you randomly choose students to answer questions in your class? Okay, so how many of you actually feel nervous about this? Come up to the stage. Many of you, right? So why do I do that? If you think about why do I want to do that? That's one, right? But more importantly is actually that I've been working on this question for how many years now? At least 7 years, right? I know every single detail, every single step. Am I the one who need to practice? I'm not the one who need to practice, right? Am I the one who's going to take the exam? I'm not the one, right? You give me the questions, I will answer the question in my own way. From my perspective, it's actually the simplest way, right? But I'm not you. How can I resemble your thoughts? It's from student, right? So if your student come up to the stage, these are the questions I'm going to ask him. Actually, everybody wants to come here. What I will do is actually first, please introduce yourself. Okay, you just say your name, your major, that's enough. Second thing I want to ask is actually, okay, read the questions. What are the keywords? Okay, and then what is the key concept that we probably want to know? Okay, and what are the equations that we want to know? Okay, so from there, how to actually solve the questions? Okay, I want to use standard students as a mediator so that you can actually see how things actually evolve. Okay, they will actually also remind you that, okay, do I thinking the same way or similar way as the student, or do I thinking the question similar way as TY? Okay, so it is very essential because only after you seeing it, you have feelings, right? Then you know how to actually improve it. All right. So let's actually why I need the student come up here. Okay, I hope. Okay, I hope everybody is actually brave enough to take this challenge. I know it's not easy. Okay, it is not easy. Okay, but trust me, I will do my best to help you. Okay, so I won't let you look bad on the stage. I will never do that to my student. Okay, but I do hope my student, after this method training, okay, you can become smart, strong, and beautiful. All right. So let's actually how do we actually pick the students? And to show you my amazing. Okay, so the things will go something like that. I just click the spin. And it's going to actually circle around for about 10 seconds. So you can see the net over there. Then we're going to have a winner. Okay. So, Antonio. Okay, so you're lucky, right? Because you know I'm not going to call you up here to demonstrate that. Okay. But this is actually how we're going to select the students. All right. We will not do this for every single questions. We will not. Okay. So what we will do is that I'm going to show you one questions. We're going to do this today. Okay. We're going to show you one questions. Okay. And then give you some practice. Okay. How we are going to do this type of question. Then we're going to go to the next question, which are similar but not the same. Okay. You're going to use similar concept. Okay. But the calculation will be slightly different because the equation you're going to use will be different. Okay. So do you see the importance to watch the YouTube video before come here? Okay, because if you already watched the YouTube videos, you should be able to actually solve all the questions in our Hangout. Okay, so and doing all these things will actually make you feel. I think will actually make the class a lot more. It will actually make more funner. Okay, so otherwise you will just hear me talking, and talking. Okay, and I become the professor that I don't like that much back to my freshman year. Okay, which I don't want to be a person like that. All right. Okay, so get back to here. Okay, so I think that's pretty much the. Do we have teamwork assignment? I don't think you have any assignment. Okay, so all the assignments actually, you only have 2 assignments per week, right? One is actual homework, one is actual quiz. Do your homework first, because there's actually no time limitation. Once you are prepared, do your quiz. Time yourself. Target is 3 minutes per question. Okay, if you can do that, then you probably actually feel a lot more comfortable when the midterm comes. All right, so do I write latest recommendations? A ton. Okay, but only after you graduate from my course. Okay, I cannot write a letter for you when you're actually in my class. There's actually a things called conflict of interest. Okay, so I cannot do that. I want to make that very clear because I receive so many requests every year. Okay, you can see I have 300 kids. Okay, there's actually a lot of requests. Okay. All right, we talk about extra credit. Okay. I skipped this. Yeah, all the review will happen in class. Okay, so I don't want to waste any of your time. I know your time is actually very precious. Okay, so everything I do will happen in class. Do we know this guy who asked this question? You haven't actually visited my YouTube channel, huh? Because my YouTube channel is actually specially says week 1, week 2, all the way to week 14. So you need to actually finish all the videos within that week. Okay, so yeah, 7 people. Okay, you better subscribe. Yes, we do. I took Chem 1 a year ago and barely remember. Is that gonna be cause me to struggle here? In the beginning, yes. Okay, not going to lie. Okay, Chem 1 is actually the foundation for your Chem 2. If you don't remember Chem 1, then you're going to have difficulty to actually understand the question, right? And many fundamentals that I won't be able to actually have time to explain. Okay, that's actually things that's going to cause you to struggle. So if that is the case for you, I would strongly suggest that, okay, once you encounter those things you are not so sure, quickly find out the answer for those things that you don't understand. Okay, how? What could be the efficient way to actually get those things resolved? My sincere suggestion is that everybody know what ChatGPT is? No? Oh, now it's a good time to actually Google and find it out. Okay, so I know like most of professor is actually against this, but I'm not. Okay, ChatGPT is actually a language model for things like this. Jenkins 1 is actually a well-established knowledge. Okay, I believe ChatGPT actually do a really good job to explain those things to you. Okay, the difficulty is that can you ask the correct questions, right? ChatGPT invention is going to become a tool that everybody should actually learn how to use it. Okay, it is kind of like an advanced version of Google. Okay, can you actually use that as a resource? That could be actually something going to help you greatly in the future. Okay, so if you encounter something that you don't understand in Chem 1, ChatGPT could be actually a good start. Okay, I know the on the canvas, it actually lists a lot of tutorial resource, right? A lot of things can be useful, okay, but sometimes it's actually not so convenient. It did not actually tailor to your specific need. Okay, so I would strongly suggest if you have some questions about the content in Chem 1, you can start with the ChatGPT to educate yourself early on. Okay, I won't be able to responsible for those knowledge because it's actually not what I signed up for, right? I signed up for teach you how to solve all these calculations, right? I'm signed up for teach you how to think about the Jenkins 2 content properly. Okay, so that's something that you plan to actually work by yourself. If there's 2 videos in the week playlist, do you watch both or one before Tuesday and one before Thursday? I guess you probably want to actually watch both, right? Yeah, so most of the video and most of it, okay? So you probably can see the things if you are careful enough. The week 1 is actually the one It's actually a video with the longest play time, like 40 something minutes, right? But after that, most of the video is actually 10, 20 minutes. Okay, so I break it down so that, you know, you can actually, you don't have to actually finish in once, you can finish through multiple trials. Okay, yeah, but trying to actually finish those things as much as you can if you actually come to the lectures. Okay. All right, so will I give equations? Yes. On your Hangout, all the equations actually on your Hangout. Okay. Is that a question? I mean, do you see all these equations? Yeah, it is here. Okay, so every single chapters we have that first page. It's a summary of the key content that you need to actually memorize. Yes. All the things you see, all the equations you see on my Hangout are the minimum amount of equation to memorize. Without this, you won't be able to solve the questions. Okay. Oh, for the constants, you don't need to actually memorize those things, right? Because you have all these periodic tables and a series of constants actually is going to show up in your midterms. Okay, you should actually see those things already from your experience from CHEM1, right? What keyword should I look for? Solubility. Soluble. Are we doing the same review sheet questions plus last class? What is last class? You mean the class taught by the other professor? So in person's lectures, we only do this hangout. Okay, so for the chapter 10, we have how many questions? 11 questions, right? We're going to go through these 11 questions as much as we can. Okay, we do the same for chapter 11, chapter 12. After that, we do the midterms. Okay. Do you recommend taking the workshop too? It's your call. Okay, you guys are adults, right? I respect you as an adult. That means actually to actually make the decision. You need to make the best decision for yourself. You also need to consider whether you have time to do so. Right. I know you take more than one courses per semester, right? How can you actually allocate your time so you can ensure in all the courses you get the score that you want? That is actually your job. Okay. So if you have time, yes. Okay. What is your favorite thing to research? We can talk about this for another hour. Okay, if you come to my office, I will let you know. Watch all. No. Why? That's too much effort. If you look at videos, okay, you can check out all the UH professors' videos. None of them is like mine. Mine is actually specially added. Okay, it's actually very short, right? All the content is actually truncated and truncated and truncated. I only actually leave the most essential contents that you need for your midterms or for your finals. Okay. So I don't think other people is going to try this. Also, Slido, come on. I haven't seen any professor trying to do this at all. Okay, because what I want to do is actually just get these things done, right? We are tier 1 university. Most of the professors, they're actually research professors. Their main job is doing research, right? I'm different because I love teaching. Okay, I spend so much time prepare my lecture materials, right? My chair actually once come to my office. He said, "Hey, Tai-Yen, you're going to submit your package next year for your tenure, right? You maybe want to actually consider cut down some time for your teaching. You think I actually spend too much time for teaching, okay? But I think it's actually a lot of fun because I feel like the student can actually feel my intention to help them to be successful, okay? So later of this semester, if you have time, I would like to actually tell you, okay, I want to actually do this survey now. How many of you plan to go to the medical school to continue your future? I see these things all the time, actually, all the time. Do you guys know how to actually prepare the materials? No, right? Do you know what are the key things they care about?
Oh, yeah.
What?
They want, I mean, like, everyone that applies to medical school probably has all these. They want the people who like go out and kind of like do stuff for their community and stuff. It doesn't even have to be like you have to volunteer at a hospital. You work at like a soup kitchen. You just have to be like, you have to make yourself like a character. I don't want to sound like it's like a big, but it's like everyone's the same. And it's like we're all in here learning chemistry. It's like you want to be the person where they're like, this guy is different than the rest. He's who we want to represent our university or the institution.
Okay, good. So you have some idea, right? How do you get an idea? Yeah, from where? From who?
My cousins.
Oh, your cousin. Is your cousin the one who reviewing the public material? It is not, right? I'm very straightforward, so don't get offended. I just want to let you know why it's actually important to actually let you know, because you have no way to actually prove those information, right? Who can actually tell you those things? Professors, right? Is professor actually tell you all this information? They don't, right? But I will. Okay, so you can see I spent so much time talking about something that's actually not related to your Gen Chem 2, right? This thing will actually continue for the whole semester. But you need to be here, right? I guess not, because I put all the recordings. But please be here so that we can actually interact. Okay, so throughout this semester, I'm going to actually tell you, okay, what it is like, okay, and what are the things you want to probably actually prepare early on, so that you can become more competitive and apply for your medical school. Okay, but that's just one example, right? The other things I want to talk about is actually research, right? Anybody actually think of actually getting a PhD in the future? Okay, a few, right? But much less than the one go to medical school, right? Yeah, so do you guys have any idea about what PhD program is like? Okay, we're going to talk about that too. Okay, so please actually stay with me. We're going to talk about things little by little. All right. When Friday 9 to 11, Fleming 139E. Okay, that's my office. 9 to 11 Friday is the office hour. Just step in, okay? So the only thing we need to do before coming into class is watch the video and take notes. Yes, easy, huh? Yeah, that's actually the only thing I ask you to do, right? So that you can actually work with me in the class. All right? Do you have memorized? This is actually how you need to memorize, okay? Where is the Hangout located? Microsoft Teams, okay? All right, so yes, we can start the class. I'm sorry I take so much time. All right, so I think that's it for now. Any other questions? Okay, if you have, make sure you actually text through the phone. Okay, so when were we last time? We talked about concentration, right? Okay, so what we're going to do today is actually we're going to trying to do a few questions in the concentration conversion. Okay, so we went through the question number 1 last time, right? Okay, so in the first questions, we say the keywords are molality and then the mass percent, right? So you have known mass percent, you want to actually convert into the molality, right? So what we do back to that time is that we first write out what is the definition of each concentration, right? And then we reread the questions and figure out what other information that we know. Okay, so the first thing we know is actually the mass percent is 8.1%. From the hangout, we say, if you start with the mass percent, you assume the mass of your solvent plus the mass of your solute equal to 100 gram, right? By doing that, you can actually back calculate the mass of your solvent, the mass of your solute, right? That's actually what we do in the first step. Then we go to molality and then trying to figure out, okay, what are the information that we need? We realize that we need the number of mole of your solute and the mass of your solvent in kilogram, right? Since we already know the mass of solvent, so the denominator is actually known. Then we actually solve the moles of your solute, okay? Then we know the moles of your solute can be computed by the mass of your solute divided by the molecular weight of your solute, right? And get the molecular weight of solute from the periodic table. You know the mass of your solute from the previous calculation. Then you can actually calculate the moles of your solute. Then you just put it back. Then you can get the correct answer. So that's actually a logical flow for the first questions, right? Everybody follow? Okay, so similarly, okay, so that's actually a logical flow. Okay, so what we're going to do now is actually we're going to do a question number 2. Okay. Now read the question number 2 carefully. This is number 1, right? Okay, so the question number 2 says, what is the molality of an aqueous solution containing FeCO3? Molecular weight or molecular mass is 162.2 gram per mole with a mole fraction of FeCO3 of 0.15. What are the keywords? Very good. So right now you can see this keyword easily, right? So I would suggest that you just write down, okay, the one that is actually known is what? The mole fraction, right? So you know the mole fraction is what? It's defined as the moles of your solute divided by the sum, the mole of solute and solvent, right? Multiplied by 100, right? Oh no, just this. Okay, that's the definition of mole fractions, right? So let's actually your starting point. Okay, what is your end point? Molality, right? So molality was defined as the moles of your solute divided by the mass of your solvent in kilogram, right? So we want to go from here to there. All right. Okay, so we know your mole fraction is equal to what? 0.15, right? So what is actually the assumption that you need to make when you start from a mole fraction? You make the number of mole of your solute plus the mole of your solvent equals to 1, right? So you know okay, so because you know the mole fraction is 0.15, right? Therefore, you know the number of mole of your solute will equals to 0.15. Number of mole of your solvent will be equals to 1 minus 0.15, which equals to 0.85, right? Any question for this step? No? Okay. I have a question for you though. What is your solute? I know the number is 0.15, but in this solution, what is your solute? This is actually your solute, right? What's your solvent? Water, right? Okay, so you know 0.15 mole. This is actually your FeCl3. 0.85 mole is actually your H2O. Right? All right. So with that being said, this is actually your target, right? The molality is actually your target, right? So in order to calculate small n, you need what? Number of mole of your solute, right? And then kilogram of your solvent. What are the things that you know? You know this, right? Number of mole of your solute is actually known, right? So you know your numerator already. Everybody follow? Okay, so what are the things that you need to figure out? Mass of your solvent, right? So do you know the mass of your solvent? Do you know the mass of your solvent? No, you don't. Okay, so what do you know? You know 0.85 mole of H2O, right? What does this mean? What is 1 mole mean? 1 mole of H2O is defined as if you have 18 grams of water, right? Over its molecular weight, which is actually this, right? So that's actually how we call 1 mole. Okay. So 1 mole is 18 grams, right? 1 mole of H2O is 18 grams. Anyone have question for this? How many mole do you have for H2O? 0.85, right? So what is the weight? Is 18 multiplied 0.85, right? Yeah, so this is going to give you a number of 15.3, right? So this is in gram, right? But you need kilogram, so you divide by 1,000, right? So this is going to equals to 0.023015 kilogram. Okay, so by doing that, you know this is the things that you need here. Okay, so you know the answer will be 0.85 divided by 0.0153. That's going to give you a value of, oh, sorry, 0.15 on the top. Yeah, my bad. Okay, so this will give you a value of 9.8 small m, right? That's how you get to that answer. Everyone follow these things, okay? Okay, so again, what is the logical flow? First, identify the keyword, right? I feel like everybody has no problem identify the keyword are mole fraction, molality. Okay, then the known one is actually your mole fractions, right? So you write down the definition first. Since we start from the mole fraction, you know the assumption you need to make is that the number of mole of the moles of solvent plus the mole of solute should equal to 1, right? And from the mole fraction, you can calculate the corresponding moles of your solvent and solute. Okay. So with this information, then you go back and check out the definition of your molality. Where you already know the numerator. The denominator is actually the one that you need to figure out. Okay. So to figure out the mass of your solvent, you go from the definition of moles, right? Because 1 mole is actually the mass over the molecular weight, where the molecular weight can always check it. Or in this case, it's actually already provided, right? Or not provided. So in this case, your solvent is H2O, right? So you can actually calculate the molecular weight. Okay, so for 0.85 mole of water, you will know what is the weight of your solvent. Okay, so you know your numerator, you know your denominator. Therefore, you can calculate the molality. Okay, so that is actually the overall thought flow for you. Okay, any questions? No? Okay. So that's for the question number 2. Let's look at question number 3. Determine the mass in gram of pentane that must be added to 10 grams of benzene to make 20 m solution. Give your answer to two decimal place. Okay, what are the keywords? Very good. 20 m solution. Okay. So why is that a keyword? That's actually only concentration unit over there, right? So what does 20 m mean? Okay, it's actually molality, right? So m is defined as what? Moles of your solute divided by the mass of your solvent in kilogram, right? So this is the keyword. And then that is actually the things that you are going to use. Okay. Then what? What are the information that you can actually know when you reread that questions? Apparently, you need to know this. So 10 grams of benzene, right? So what is your benzene? Solvent or solute? Solvent, right? Can you actually see benzene is actually the solvent? Okay. You need to read this question again. Okay, make sure you can understand that. Okay. So you have 10 grams of benzene, right? Benzene is your solvent, right? So what is your MB? Right. So you actually can know your MB already, right? But this one needs to be converted to kilogram, right? That's the only thing that you need to do. Okay. And then what? Need to figure out the things on the top, right? So definition of your moles of your solute is equals to the mass of your solute divided by the molecular weight of your solute, right? That's actually how you define the moles, right? The mass of your solute divided by the molecular weight of your solute. Okay. In this case, your solute is what? Pentane, right? What is the molecular weight of pentane? 72. That's actually the molecular weight of your pentane, right? Okay. What's the mass? Yes, the mass is actually you are looking for, right? So the mass is actually unknown. Let's say something that you want to know. Okay. So you know this whole term is actually equals to this term, right? And then you know the concentration of your solution is what? 20, right? That means actually your number of mole of your solute over the mass of your solvent is going to equals to 20, right? And then the mass of your solvent is 10 gram divided by 1,000. Because you have a unit of kilogram, right? So with that being said, you can know that the number of mole of your solute is going to equals to 20 times. Yes, right? And then you also know this is going to equal the mass of your solute divided by 72.15 gram per mole. And this is going to equals to, this will be 50. And then it will be 0.2, right? So your mass of your solute will equals to 0.2 multiply 72.15. Okay, and that's how you solve this. Any questions? Then over 1,000 is actually you convert the gram into kilogram, right? Because 1 kilogram is actually 1,000 gram. Okay, this is just convert the unit conversion. Okay, so you got the mass in kilogram. Okay. That's okay over there. The line is actually doing something weird. Feel free to actually move around on the line. Okay. All right, so this is actually how you solve question number 3. Any questions? Yes. How do I determine the solvent and solute? Okay, very good questions. Okay, so in this specific description, it's actually somewhat not so clear, right? But one thing it says here is actually you add something into something else, right? So typically you add the solute into your solvent. Okay, so I agree with you. Okay, so if you want to say this question is actually not well designed, I'm fine with that. Okay, but my feeling is that they intentionally test you whether you can actually read the sentence and figure out who is actually the solvent, who is actually the solute. Does that answer your question? Okay, good. Any other questions? Hmm? Okay, so again, all these things will be uploaded today, okay, onto our Teams. Okay, so if you have any questions, make sure you should go back and recheck it. Make sure you understand things, okay? And then do it quickly, okay? Don't wait. Okay, the waiting is actually going to kill you. All right, so let's actually how you solve question number 3. Question number 4. A 5 mass percent aqueous solution of nitric acid has a density of 1.05 gram per liter. Calculate the molality of the solution. What are the keywords? Mass percent and molality, right? So again, you're going to see the same pattern. The pattern is actually repeating, right? Identify keywords. know what you know, right? Write out the definition of your concentration terms, right? And then write out the things that you know. Check out the things that you don't know. That's always like that, okay? So mass percent is defined as the mass of your solute divided by the sum of solute and solvent, right? Multiply 100%. Okay, so let's actually the definition of mass percent, right? And you want to calculate the molality, which is defined as moles of your solute divided by the mass of your solvent in kilogram. Okay. So since you start with the mass percent, right? What is actually the assumption that you should have? Yeah, 100 grams, right? So your mass of your solute plus the mass of your solvent is equals to 100 grams. Right? And then since you know your mass percent is 5%, right? That means actually your mass of your solute is 5 grams. Mass of your solvent is 95 grams. Right? Any questions for this? We are in question number 4. Okay, so these are the things that you can actually know once you make that simple assumption, right? Now you want to actually turn the focus into here. You know, let's actually definition of your molality. Okay. Do you know the mass of your solvent? Yes, right. 95 grams, right? In terms of convert into kilograms, so 95 divided by 1,000. That's actually your mass of your solvent. Right? How about the moles of your solute? In order to calculate that, you need to know what? The mass of your solute divided by the molecular mass of your solute, right? Do you know your mass of solute, which is 5 grams, right? What is the molecular weight? 63.01, right? So let's actually your denominator, and then your numerator is simply 95 over 1,000, right? So by calculating this, you can get your final answer of 0.84 m. Yes, per mole. All right. Any questions for this? No one have questions for this? Yes. Yes. You don't need the density, right? So why do I put the density over there? To confuse you. See? So sneaky. Right? But this actually have effects because you know what? There's so many students. They will just ponder, okay, I did not use the density. Do I do the calculation right? Okay, when you have let's solve, what happened? Lost your time. Okay. So you can see all these questions are actually designed in a way trying to confuse you as much as you can. But if you follow our logical thinking, you will know you don't need that information at all. Right? That is the things you need to practice. That is the things I want to let you know so you can see business clearly. All right. So starting from the keyword, go to the definition is absolutely needed. It saves you time. It prevents you from confusing yourself. Make sense now? Okay, so make sure you see these things. All right, running out of time. Number 5. Okay, number 5 is actually another very interesting question that many of you will not be able to answer correctly. Okay, so this is actually not about it's actually not about the concentration conversion anymore. Okay, but I put it here because I want to actually talk about these things specifically. Okay. Let's read this question very carefully. How many moles of solute particles are presented in 50 ml of 3N Na3PO4? Okay, the question is actually very short. How many moles of solute particles are presented in 50 ml of 3N Na3PO4? What are the keywords? Or what is the keyword? Moles, right? And the concentration term. These are 2 keywords, right? Okay, so apparently the things that you know is you have 3M, right? From here, we should know that the definition of your molarity, capital M, is equals to the moles of your solute divided by the volume of your solution. Right? This is the equation that you need to memorize, right? Okay, so once you write it down, then you start to figure out what are the things that you know. Do you know the volume of your solution? Okay, so it is 50 ml, right? But your volume need to be in liters, right? So this needs to be divided by 1,000, right? So you know your denominator is this. No problem at all, right? Do you know the number of mole of your solute? No, at this moment you don't know, right? But you do know the concentration equals to 3, right? So you should be able to write these things without any problem, right? Okay, so from here, then you know the number of mole of your solute will simply equals to 3 multiply 50 over 1,000. This gives you a value of right? So far, so good. Okay. Then what? Is this your answer? So what is your answer? Okay. So this is actually a very important concept, right? This is what? The number of mole of your solute. It is not the number of mole of your solute particle. Okay, so this words. Okay, let particles circle it and make sure you know it's asking for the particles, not just the solute. Okay. Once you see these keyword particles, means actually the substance that you originally consider is actually a solute. It will dissociate, right? So you know you have Na3PO4. This will become 3 Na plus PO4 3 minus. Okay. Any question for this? This is so-called the soluble salt. Okay, once you dissolve inside waters, it does not stay in the Na3PO4 form anymore. Instead, it becomes 3 Na plus and 1 PO4 minus. Okay. So you know one of this is going to give you 4 particles. Okay. When we calculate the concentration, this 0.15 mole is how much of Na3PO4 that you have originally. Okay. But since it is a soluble salt, you know 1 mole of that is going to give you 4 mole of particles, right? We call this 4 as a Van Hoff coefficient. Okay. Since in this specific question, it asks how many mole of solute particle. Therefore, the number of mole of your solute particle is going to equal to the number mole of your solute multiply your Van Hoff coefficient. In this case, going to equals to 0.15 multiplied by 4. That's going to give you a value of 0.6. Okay. Yes. PO4 3 minus. Can 1. Okay. But we're going to talk, I don't know we're going to have time to talk about this, but this actually content from Can 1. Okay, so what are the species that are going to dissociate when you store in water? Electrolyte, right? There are 3 types of electrolyte. One is acid, one is base, one is salt. This is a salt. Okay, Na3PO4. How do I know it becomes 3Na, 1PO4 minus? The way you make the judgment is actually if you look at the periodic table. Okay, 1A group prefer to present in 1 plus. 2A group like to present in 2A plus. Okay, sodium is actually 1A, right? So it like to stay in the Na plus. Okay, so that's why I write on the Na plus over there. Right, so if you look at your salt, you have 3 Na, right? Therefore, I put the coefficient 3 in front of the Na plus. Okay, and actually, that salt actually typically is going to associate with something look complicated. The commonly thing one is PO4 3 minus. This is actually something you want to actually memorize it. So that once you see PO4 minus, you know, once it dissociate, it will become PO4 3 minus. So this is actually something that you need to memorize. There's actually another one, another very famous one you need to memorize is SO4 2 minus. Okay. That is actually a very famous example, right? Okay, so this is actually electrolyte, the acidic electrolyte, because you know it produces H plus, right? Proton. Okay, so in this case, the I is going to equal to, what is the I for your H2SO4? 3, right? Because you know 1 mole of this give you 3 particles. Therefore, the I is equal to 3. All right. Okay, so let's actually how you solve question number 5. Okay, let's solute particles is actually a very important concept. Yes. A little bit louder, I cannot hear you. Sorry. They are actually equivalent. All right, so we want to go to the very last important concept for this chapter. Okay. I guess I talked too much in the beginning. I'm kind of falling behind now. The class is actually to 5:30, right? Trying to actually give you 10 minutes to leave the room, so we still have around 5 minutes. Okay, so we'll go through a concept quickly today. Okay, you can actually go back home and practice all the remaining questions. Okay, we'll actually finish those questions on Thursday's lecture. Okay, and be prepared. On Thursday, I'm going to call some student up and then trying to do this question together with me. Okay, so the very last important concept of this chapter is called the collective property. Okay. Here, I know it looks complicated. Okay, but the really important things is that this is a property is only relevant to the number of particles you throw into your solution. Okay, the more particles you store in the solution, the corresponding property is going to change. The property I'm talking about is vapor pressure, boiling point, freezing point, and then the osmotic pressure. Okay. So these are the 4 keywords. Okay, so it means actually when you read the questions, you're going to see these things. Okay, so if you're actually talking about the vapor pressure, then you know you either use this equation or the equation. If you're talking about the boiling point, that's the equation you need to use. Okay, so on and so forth for your freezing point and the osmotic pressure. Okay, so this properties is actually all related to the effect of those particles. Okay. One thing that you should have in mind is that inside your solution, okay, when you talk about the vapor pressure, boiling point, freezing point, and then osmotic pressure, this is the property of your solvent or solute. Solvent or solute? Solvent, very good. Okay, it is a property of your solvent, not a property of your solute, right? Because the vapor pressure is actually coming from your bulk part. Okay, the bulk part is actually your solvent. Okay, so let's talk about the boiling point first. Let's say you have a solution. Okay. Example is actually sodium chloride aqueous solution. Okay. In this specific case, your solvent will be water. Solute will be sodium chloride. Right? If you're throwing a lot of sodium chloride, what people find out is actually the boiling point is going to increase. Always increase. Okay. You should notice that here I say the vapor pressure lowering, meaning if you throw in more solute, the vapor pressure will decrease more. Boiling point elevation, you throw in more solute, the boiling point of your solvent will increase. Freezing point is going to decrease. Okay. Osmotic pressure is going to change as well, depending on this equation. Okay, so why though? Okay. Of course, you can go back and watch the YouTube video. Okay. Here, the things that you want to have in mind is that all the things we talk about is actually property of your solvent. Okay. Using boiling point as an example. The boiling point is actually the temperature where your liquid molecule vaporize, right? When the liquid molecule vaporize, inside this solution setup, it's going to happen at the surface between your liquid and your air, right? When you throw in a lot of solute, okay, doesn't matter what it is, what's going to happen is actually going to do this. It's going to cover part of that surface area. Okay, so once you do that, what is actually the gas, the solvent want to evaporize, but the first step is actually to go to the surface. But right now the surface is actually covered by your solute, right? That means you need to actually heat your solution harder to make this process become feasible. Okay, so that eventually it will actually evaporate. Okay, and then the net effect is actually it result in once you throw in more salt, you need to actually go to a higher temperature to make it evaporate. Therefore, what you're going to see is that the boiling point is going to become higher when you have higher concentration of solute. Okay. Similarly, your freezing point is going to decrease. Okay. So the concept you should have is actually, in order to make your solution freeze, what means actually to actually make your solvent molecule start to align in a periodical way to form the ice, right? If there you have too many solute inside, it's going to break that periodicity. Therefore, it's actually more difficult for them to actually align properly. So that the net effects are to actually lower down the temperature to make those things happen. Okay, so that is why it doesn't matter what kind of things you throw in. Okay, once you have that, you actually occupy the space that prevent the change actually the normal boiling and freezing point. Okay, so those are the things that we should know. Okay, and in the next lectures, we're going to use this concept to solve the questions from question 8 to 11. All right, so we'll stop the lecture today. Thank you.